Hello students, welcome to my channel CGAT, CGAT Maths. Myself Dr. Suresh brother. In this video, we are going to discuss statement and proof of Cauchy-Riemann equations in polar form. Cauchy-Riemann equations in polar form. Fine. First, let us define the statement. Then we are going for proof. Fine. Statement. The necessary condition for the complex valued function fz is equal to u of r comma theta plus iv of r comma theta may be analytic at the point z is equal to r e raised to I theta is that there exist 4 continuous first order partial derivatives dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta, and satisfies the equations dou u by dou r is equal to 1 by r into dou v by dou theta and dou v by dou r is equal to minus 1 by r into dou u by dou theta, or simply ur is equal to 1 by r into v theta and vr is equal to minus 1 by r into u theta is the statement of Cauchy-Riemann equations in Cartesian form. Now let us go for the proof. Okay, proof is very easy. Just look at proof. Given fz is analytic at z is equal to r e raised to I theta, by definition of analytic function, analytic function f dash of z, or you can also write dw by dz is equal to limit as delta z tends to 0 f of z plus delta z minus f of z divided by delta z exist, and it should be unique at Z and in the neighborhood of Z. Okay, so call it as some equation number 1 for this f dash of Z. Okay, fine. In the polar form, okay, in polar form, f of z is equal to u of r comma theta plus iv of r comma theta, and what is f of z plus delta z? So we have given increment to z, z becomes z plus delta z. Correspondingly, r becomes r plus delta r, theta becomes theta plus delta theta plus iv into r plus delta r comma theta plus delta theta. Fine. Similarly, we know that z is equal to r e raised to I theta. By using total derivative rule, we know that delta z is equal to dou z by dou r into delta r plus dou z by dou theta into delta theta. That is total derivative of z with respect to r and theta. What is the value of z with respect to r? With respect to r, e raised to I theta is constant, r is 1. Similarly, what is z with respect to theta? So r is a constant. Differentiation of e raised to I theta is e raised to I theta. Again, I theta is I. So you will get I r e raised to I theta. So now it will become dou z by dou r is equal to e raised to I theta into delta r plus dou z by dou theta is I r e raised to I theta into delta theta. So finally, delta z becomes e raised to I theta into delta r plus I r into e raised to I theta into delta theta. This is the value of delta z. Fine. Now equation number 1 becomes, just look at, substitute the value of f of z plus delta z and f of z. Now equation number 1 becomes fine. F dash of z is equal to limit as delta z tends to 0. F of z plus delta z is u of r plus delta r comma theta plus delta theta plus iv of r plus delta r comma theta plus delta theta minus u of r comma theta plus iv of r comma theta divided by delta z. Fine. Now I'm going to take real and imaginary parts separately. F dash of z is equal to limit as delta z tends to 0. Real parts means u, imaginary part means v. So take first write u of r plus delta r comma theta plus delta theta, here minus u of r comma theta and iv of r plus delta r comma theta plus delta theta, here minus iv of r comma theta, so you can take I common and write the remaining one, that is v of r plus delta r comma theta plus delta theta minus v of r comma theta divided by delta z. In the next step, since delta z is the LCM, I'm going to write limit as delta z tends to 0, u of r plus delta r comma theta plus delta theta minus u of r comma theta divided by delta z plus I into v of r plus delta r comma theta plus delta theta minus v of r comma theta divided by delta z. In the next step, what I will do is I am going to apply the limit of a sum. Fine. That is f dash of z is equal to limit as delta z tends to 0, u of r plus delta r comma theta plus delta theta minus u of r comma theta divided by delta z plus I times of limit as delta z tends to 0, v of r plus delta r comma theta plus delta theta minus v of r comma theta divided by delta z, and call it as equation number 2. Fine. Now we have two cases here. Case 1. So as we know that we have delta z is equal to e raised to I theta into delta r plus IR e raised to I theta into delta theta. Just you can check once. Delta z is equal to e raised to I theta into delta r plus IR e raised to I theta into delta theta. Now here I am going to substitute delta theta equal to 0. If delta theta equal to 0 means delta z becomes delta z is equal to e raised to I theta into delta r, and as delta z tends to 0, then e raised to I theta delta r tends to 0, or simply delta r tends to 0. Fine. Now the equation number 2 becomes f dash of z is equal to limit as delta z becomes delta z tends to 0 means delta r tends to 0. U of r plus delta r comma, you can take delta theta equal to 0, then you have just theta minus u of r comma theta divided by denominator delta z is replaced by e raised to I theta into delta r plus I into limit as delta r tends to 0. Here also V of r plus delta r right as it is. Substitute delta theta equal to 0, then it is just theta minus V of r comma theta divided by denominator delta z is equal to e raised to I theta into delta r. And look at this expression carefully. That is f dash of z is equal to, in both the term, 1 by e raised to I theta is common. The remaining is limit as delta r tends to 0 u of r plus delta r comma theta minus u of r comma theta divided by delta r is the definition of partial derivative of u with respect to r plus I into this will become partial derivative of v with respect to r and call it as equation number 3. Fine. Now let me go for case number 2. What is case number 2? As usual, you know that we have delta z is equal to e raised to I theta into delta r plus ir e raised to I theta into delta theta. Now you can substitute delta r equal to 0 this time. Delta r equal to 0 means delta z becomes ir e raised to I theta delta theta. And as delta z tends to 0, which implies that this right side tends to 0 or simply delta theta tends to 0. Fine. Now equation number 2 becomes f dash of z is equal to limit as this time delta theta tends to 0 u of r plus delta r is 0 comma theta plus delta theta minus u of r comma theta divided by delta z. Delta z is equal to, can substitute this total, that is I r e raised to I theta into delta theta plus I times of limit as delta theta tends to 0 here. Since it is delta z tends to 0, as delta z tends to 0, then delta theta tends to 0. V of r and delta r is 0, comma theta plus delta theta minus V of r comma theta divided by this is I r e raised to I theta into delta theta. And try to observe carefully. Here f dash of z is equal to, what is common in both the term? Look at here. Here I and I get cancelled, and common terms in both the expressions are 1 by r e raised to I theta. And look at remaining one. Remaining is limit as delta theta tends to 0 u of r comma theta plus delta theta minus u of r comma theta divided by delta theta. It is the partial derivative of u with respect to theta, and there is a 1 by I outside, plus the remaining one becomes dou v by dou theta, and call it as expression number or equation number 4. Or before calling equation number 4, now try to expand this. Just this is f dash of z is equal to 1 by r e raised to I theta. As you know that 1 by I is, I will write once again, 1 by I is equal to multiply and divided by I. So this will become I square in the denominator. I square equal to minus 1. So I by minus 1 is minus I. So I am writing this is minus I into dou u by dou theta plus dou v by dou theta, and call it as equation number 4. Now compare equation number 3 and equation number 4. In both the equation, left side are equal, that is f dash of z. So definitely the correspondingly the right side is also equal. So what is right side of both the equations 3 and 4? One by e raised to I theta into dou u by dou r plus I into dou v by dou r is equal to 1 by r e raised to I theta into minus dou u by dou theta minus I dou u by dou theta plus dou v by dou theta. Look at both sides, 1 by e raised to I theta, 1 by e raised to I theta get cancel, and try to observe. And you equate real and imaginary parts. The real parts are dou u by dou r in the left side, the right side dou v by dou theta, and it is multiple of 1 by r. So equating real and imaginary parts, dou u by dou r is equal to 1 by r is the multiplier into dou v by dou theta, and imaginary part dou v by dou r is equal to, this is minus 1 by r into dou u by dou theta. These are the Cauchy-Riemann equations in the polar form. Thank you so much for watching. We'll meet in the next video.